Hello, hello. Can you guys all hear me? Welcome to Hoot episode 53. Today we're going to talk about cut service mesh overhead by 90% or more with Istio Ambient Service Mesh. I'm so excited to be back with this Hoot. I feel like I haven't run an episode for a very long time. Are you concerned about your service mesh overhead? Do you want to pay less for cloud infrastructure resources from Service Mesh? Today, I am so happy to have Greg Hanson, who I believe spoke about Hoot multiple times. I think one time about debug Envoy configuration, the second time about what ambience means for your wallet. If I remember correctly, Greg, maybe there's more time. Why don't you go ahead, introduce yourself before we jump into cut service mesh overhead topic with Istio Ambient and the new RAS-based ztunnel.
Sure thing. Thanks for the intro, Lynn. But yeah, I am Greg Hanson. I've been with Solo now for a little over a year, but I've been working on Istio since kind of day one. So I've been spending a lot of time with it. And of course, the latest thing that everybody's talking about is Istio Ambient. And so one of the things that I've been doing a lot of is kind of running Ambient through some performance tests and seeing what that means for your wallet. So yeah, in the past, I kind of did a similar discussion for, back when we first released Ambient as its like pre-alpha release with the initial announcements and everything back in, what was that, September, Lynn?
September last year?
Yeah,
Yes, it's almost a
gosh,
year ago.
I know it's coming up. Ambient's going to have its year birthday here soon. And
Yeah.
then, yes, yep, the other hoot that I did a talk on was, yeah, debugging Envoy configuration.
Which, by the way, is one of our most popular hoots since last year.
Yes.
Yeah.
Yeah, and that one, let's see, I spent a lot of time looking at Envoy access logs as a developer for Istio, and so one of the things that I did was I wrote myself a little tool for parsing access logs, so I wouldn't have to pull up the Envoy documentation page anytime I needed to see what a particular field was or what a certain error code meant. And of course, I also wanted to share it with everybody who kept coming to me and asking me, what does this access log mean? So I was looking to take a little bit off my shoulders there.
Yeah, I mean, great tool. I use it myself when I need to debug something myself. So yeah, so thanks for educating our community. Now let's jump on to our today's topic. So before I jump on to today's topic, I just want to level set. Everybody knows Istio 118 went out in early June, I believe, and Ambient is included as part of Istio 118 as an alpha feature. Istio Day is also calling for submissions. So if you are an Istio user, we would love to have you submit for Istio Day. It's a co-located event as part of KubeCon. And Istio CNCF graduation is progressing really well. So finger crossed, we're going to get that really out soon. It already passed all the TOC votes. So really good. So Greg, can you explain what service mesh overheads mean, right? When we talk about service mesh overheads, I'd like you kind of give a quick intro to our audience about, what is the overhead in terms of running Istio with Sidecar? What is the overhead in terms of running with Ambient?
Sure thing. So, with a service mesh, there's lots of features that everybody likes to see, like authentication, authorization, load balancing, traffic routing, policy enforcement, telemetry, and observability. And so, service mesh overhead is going to be any additional resources that are deployed on your cluster in order to leverage those features. So, those overheads are going to include things like additional CPU consumption. Since we're running additional components on your cluster, there's going to be more CPU usage there, and the same thing goes for memory. And then also the other one is latency. Since there is an additional component in the request path for all of your applications, there is a little bit of delay there. But for the sake of this talk, we're just going to focus on memory and CPU usage and not the latency. So with regards to sidecars, that service mesh overhead is, there's two parts of a service mesh, and that's kind of broken up into the control plane and the data plane. So the control plane, that's the part that's processing all the knobs, buttons, features, APIs, and CRDs that exist to create all these features that you want. And then there's the data plane portion, which is the part of the service mesh that's directly involved in the life of a request in your application. So let's take a look at how, I guess, the two different architectures, sidecar and ambient, impact the service mesh overhead. So with sidecars, obviously, the main service mesh overhead is the sidecar. It's an additional container that runs in every application pod in your cluster. And historically, for Istio, that additional container is running an Envoy process. And in ambient, there is no sidecar. And instead, it's replaced by two separate components. ztunnels are a brand new Istio component written in Rust and are designed to be fast, secure, and lightweight. And these are deployed per node and serve all nodes serve all pods co-located on that node. And they enable basic mesh configurations for L4 features such as mutual TLS, telemetry, authentication, and L4 authorizations. And then the second new item is a waypoint proxy, which provides L7 mesh features such as virtual services, L7 telemetry, and L7 authorization policies. And waypoints are still based on Envoy, but these are deployed per namespace or service account rather than per application pod. So in terms of what ambient means for that overhead is now your applications scale independently for that the data plane portion of service mesh. So if you need to bump up the number of replicas for a certain application, you don't see that cost reflected in the number of sidecars that you need to deploy because there is no sidecar. So I think I covered that. Did I miss anything there, Lynn?
No, that's good. Just to recap for our audience. So essentially, for service mesh overhead, there are control plane and data plane, right? So control plane, you have to pay regardless whether you run sidecar with ambient, which is without sidecar. But the difference, I would say, is we do expect much less data sending from the control plane to the data plane in the sidecarless mode with ambient. And then in sidecar mode, you have to pay for the sidecar. And then in ambient mode, you have to pay for the ztunnel and waypoint, like Greg described, right? And typically when you pay for those costs, you pay for whichever the CPU and memory, and then the data transfer cost in your cloud that you reserve. So with that, Greg, I want to ask you the next question. So what are the savings with ambient from your testing compared with sidecar from a user perspective? Because one of the biggest things we do think users are interested in ambient is to save their infrastructure cost.
So there's two different savings that you can look for, and that's in your usage improvements and your allocation. And just to kind of go into that usage versus allocation, typically in a cluster, the number of nodes determine the overall capacity of that cluster. And like the pods that are part of your customer deployments are an allocation of that capacity. And whereas usage is a measure of how well that allocation is actually used. And so one of the things that I keep an eye on throughout my tests here are specifically usage, and then also the initial allocation that is required to, I guess, deploy things and get things running. So in terms of what users can expect. So in my particular example, I was seeing 90% savings on allocation. So that's just a flat reduction of like the size of your cloud and the final cost that you end up paying for you're paying per node for that CPU and memory associated with it. And I don't know, for like memory, I was seeing 90% cuts. So I guess to clarify,
Should
and
I bring
yeah,
up your screen, by the
yeah,
way?
sure.
Okay.
That's a good idea. And so I have these graphs here from a few different scenarios. So it's kind of broken up into three different segments. Um, so let's just take a look at memory usage, for example, here. So I run three different tests. The first one is specifically just the sidecar scenario. So every application that's deployed has a sidecar with it. And then this middle scenario here, I call the ambient scenario, which is just L4 only. So only Z tunnels, no waypoints. And then over here on this side, this last segment, that's ambient with L4 and L7. So now waypoints are added into the mix in addition to the Z tunnels. And so just kind of looking at this, so each one of these lines here that are all clustered together, all compact, are a Istio proxy Envoy process. And they're consuming about like 48 megabytes of RAM. But then down here in the ambient only scenario, there's just Z tunnels, and each of these Z tunnels is using about 14 megabytes apiece. So I have 144 application pods. So in this first segment, there's 144 sidecars. But then with only the L4 ambient scenario, there's just 3 Z tunnels. And those Z tunnels are using a fraction of a individual sidecar in terms of memory. In fact, almost all 3 of these Z tunnel processes combined is just a little more than the cost of running one sidecar. So just right there, memory, lots of savings.
Yeah.
Now, of course, when you get to the ambient L4, L7, there are some waypoints in here, and we expect those to perform similarly to the sidecars because they're still based on Envoy. And Z tunnels do see a little bit of increase just because now they need to upgrade the traffic into something that the waypoint Envoy proxies can handle. But once again, there are significantly fewer waypoints and Z tunnels in comparison to the sidecar model. And that
By the way,
is,
what you were
oh,
just showing, is that usage of the...
yes, to
Okay.
clarify, yeah, this is actual usage for the individual proxy containers. So
Yeah, this
sidecars,
is...
Z tunnels, and waypoints.
Yeah, this is really impressive data. When I first look at the data, I feel like it's almost too good to be true, right? Because like you said, 3 of your Z tunnel is about 1 memory usage of a sidecar, and also the fact that waypoint can scale independently out of your application pod, that allows us not needing to run as many as waypoint as application, right? Which is on your graph. There's way less number of waypoints compared with sidecar, which is an additional saving as far as the memory.
Correct. Yep. And I mentioned earlier, the Z tunnels were written in Rust and they were designed to be fast, secure, and lightweight. And this is just a great example of what that means in terms of resource consumption. And I mentioned memory, and I do want to pull up CPU as well. So sidecar scenario, all of your sidecars are down here using about 0.02 of a single CPU. And Z tunnels do use more CPU in this case, but once again, each of these Z tunnels are basically, each Z tunnel is handling 144 divided by 3. What is that? 48
50,
services.
yeah, yeah.
So it's expected to be just a little bit more CPU usage, and similarly for when waypoints are added in. But the main thing we have to think of is the total usage across that entire cluster. So like RAM, going back to RAM. So this is uh, every Istio part of the data path. So sidecars in the first scenario here, and this little yellow line along the bottom is when only ztunnels are used, and then ztunnels plus waypoints here at the end. And the difference between sidecar and the L4 scenario, that's 99% savings, greater than 99% savings, actually. And in this particular example, that's about, oh gosh, what did I have? 88% savings in memory usage there. So it's still a significant reduction in what you need from a memory perspective just to run Istio in your mesh.
Just a quick question. In this diagram, it's only the infrastructure, service mesh infrastructure RAM. It doesn't include the actual application, which is the boutique app used in your test. Is that right?
Correct. This is, yeah, just the Istio components. And now I mentioned that ztunnels used a little bit more CPU, but what does that translate for the totals across the mesh? It's still a pretty big reduction. For instance, here, this is about 1 CPU, and here it's a little less than 0.2, so that's over 80% in savings right there if you only need to run ambient with L4s. And once you add in waypoints, the savings are not as high, but still that's a 40% savings, running at about 60% of what the sidecar model does. And I suppose to clarify, I mentioned the L4 and the L4 plus L7 scenarios. And that's a big part of choosing ambient is also what you need for your mesh. If you just need that L4 mutual TLS to check that box on your security audit, then I mean, ambient is for you because that's where you're going to see the most savings. But if you start needing to do like virtual services for routing between different versions or across different zones, that's where waypoints are going to come in. And so if you don't need it, you don't need to deploy them. And that's where the savings come in.
Yeah, and one comment I would make is at KubeCon, I talk about how to use Argo rollout to roll out the newer version of your application. So one interesting thing about ambient architecture is when I have a new version I need to roll out, I can deploy my waypoint. And when I'm done with rollout, I don't need my waypoint. I can actually remove my waypoint if the whole purpose of the waypoint is just to help me rolling out a newer version of my application. So that's the other thing to consider, the factor of with ambient architecture, the waypoint runs outside of your pod. So you have that flexibility to kind of pay only when you need it.
And I don't think I've gone over this yet, but just a quick explanation of the actual demo that I have running in each of these test scenarios is I'm actually using what is called the online boutique microservices demo, which is out here on GitHub for people to play around with. And so what I did was I deployed 4 different instances of this in 4 different namespaces. And then I scaled each of the application instances. There's 12 applications in each online boutique instance. And I scaled those up to 3 instances each, just to replicate minimum 3 HA high availability deployment best practices. And so 4 namespaces, 3 replicas each, 144 pods total, 36 services in each namespace. Or sorry, 36 services total, 12 in each namespace. And then Oh, sorry.
I think the other thing was clarify maybe is as a user, you actually, what you are presenting is the actual usage of CPU, of memory. But as a user, that's not necessarily what you pay, right? It's like
Yeah.
you have a laptop. Yeah, my laptop, I think it's 64 gig, and I don't always use 64 gig, right? If I'm using 16 gig, I still pay for that 64 gig because that's the contract that I signed up as a user. When you go to a cloud provider, I need this much memory, regardless whether you're using that much. That's whatever you would end up paying because that's the requested resources from a user.
Yeah, and so I have a nice table about that in terms of allocation for this particular example. The thing with sidecars is they define a high minimum for allocation at any scale. Uh, for instance, every sidecar has a minimum resource request of, I believe it's 100 millicores and I forget how many megabytes RAM, but so that's the bare minimum number of resources that you need to actually just get a sidecar to deploy. And so what that means is you have that times, in this example, times 144 sidecars. Now, in my particular example for these services to deploy, I had to use a 3 node test environment, each with 16 CPU and each with 64 gigabytes memory. And that's most specifically just to get the sidecar example running. If I was just doing the ambient scenario, I could have deployed a much smaller cluster environment and I would have been able to run the test fine without shelling out the bucks. And so that's kind of like what I showed here. So just using this example with 144 sidecars, you need this minimum of 18 gigabytes RAM. Whereas in the ambient only scenario, you only need 384 megabytes and a little less than 2 gigabytes with L4 and L7. And
Mm.
same thing goes for uh, the CPU cores. It's 0.3 for the L4 and 1.5 for L4 with L7, but you need a whopping 14 cores for the sidecar example, just to deploy. So without even stress testing your mesh environment, with how many requests you're throwing through it at any given second, this is just to deploy things, and you're already seeing this 90 to 98% savings there, depending on what you want to run. And if you actually look at the Google Cloud uh, node cost with the GCP monthly pricing, you can actually put a like $3.33 per 1 gigabyte per month cost, and about $23 per month for one CPU. So you can actually calculate how much money you can save by switching to ambient, and it shows.
Yeah, definitely. That's probably why we've seen people tweet about service mesh infrastructure is eating a lot of their CPU and memory on Twitter too, right? The sidecar constantly use a lot of resources. So I think the saving you have, it's really impressive, right? And I remember two numbers. One is 98 percent of saving, and the other one is 90% of saving. I believe the former one is memory, the other one is the CPU. So that's kind of my key takeaway from this exercise when compared with sidecar to ambient.
Yeah, but I think it's pretty exciting, and all these scripts and dashboards I have pushed up to GitHub too.
Nice.
Yeah, I'm that confident that no matter what your test environment, you're going to see some savings, and I want people to try this and have their mind blown and see exactly what it means for them for their specific deployment.
Yeah, that's a great point. So everything is open source as far as this test and dashboard.json. So we actually want to hear from you to see, do you see similar results of saving in your environment with your application? We've tried, Greg has tried HTTP being now online boutique app, which is a little bit more realistic app. So definitely comment and let us know. All right. Is there anything else, Greg, you want to quickly mention before we wrap it up?
Um, no, I think that's it. Did we have any questions come in on the live
I
stream?
I don't see any questions, and I don't know how to see the question on LinkedIn. I only know how to see the question on Twitter. So.
All right.
All right. I don't see any questions coming in, so I guess I would try to wrap this up, Greg, unless you have any parting thoughts you want to share.
Go try Ambient.
Yeah, that's a good one. And let us know how much saving it can save for you. Whether the 90%, 98% makes sense for CPU and memory in your environments. And also, on top of that, right, there is also the simplified operation benefit, which I always believe that's the number one benefit, and the infrastructure cost is the number two benefit with the service mesh overhead. All right. Thank you so much, Greg, for your time and prepare the live dashboard. I believe the work you are doing is going to be published on Istio.io as well. Is that correct?
Yep, fingers crossed. Hopefully, just waiting for some final approvals, and then my blog will be out there for everybody to read.
Awesome. That's great. Well, thanks to you, Greg, and thank you everyone for joining. We'll see you in 2 weeks for another Hoot episode. Thanks. Bye.